Assalamualaikum and a very good day to all of you. So for Wide Area Network class, for today's lab 9, we will learn about exterior border gateway protocol, which is eBGP. So in this lab, you will learn about the single homed eBGP. You need to understand that BGP is usually not necessary in a single home. It can also be a multi-homed. So but for the lab purpose, due to its simplicity, so I'll just show you how to configure and verify the single homed eBGP. So what is the difference between single homed and multi-home? So a single home BGP setup refers to a router or site that's connected to only one ISP as shown in the topology, with no redundancy or backup via multiple providers. So in this case, if you see R1 and R3 is connected only to one ISP. So for multi-home, so there should be another ISP connected to R1 or to the R3 to provide backup. So in this topology, it is a two single home. So R1 is connected to ISP and R3 is also connected to ISP. If both of the R1 and R3 is connected to ISP1, meaning R1 is connected to ISP1 and R3 is connected to ISP2, so it is the same single home topology. So in this diagram, all the R1 and R3 is connected to the same ISP via eBGP with an IPsec VPN between them. So what happened here is I will show you how the ISP can advertise the default route from the ISP to the border router R1 and R3. So for that purpose, we need to make a preparation and remove some of the configuration from the previous lab. So the packet tracer that I use is the lab 8 packet tracer, which is the IPsec VPN. So there is no changes on the IPv4 addressing table. So what we will do first, we will enable BGP routing, configure BGP neighbors, or what which is the BGP peering process, and then the ISP will advertise network originating from the AS and verify BGP routing. So to understand further, the details of the BGP setup is as in the table. So you can see that we have 3 routers there, and we also have tunnel. So for R1, we will give the autonomous system number, the ASN number 65001. R3 and the connectivity from R1 to there must be a connectivity single eBGP link to the ISP. So the ISP number is 65002. So for R3, the ASN number is 65003. So without further ado, we will do and prepare and make some modification for lab 8, the IPsec VPN packet tracer, and we will do some tests first before the modification is made. So first of all, this is my packet tracer. Okay, so basically here, lab 9 EB4. So I'll just save it from the IPsec. So let me exit first, okay, to avoid any confusion. So here I have already marked R1 with their S number, which is 65001, ISP S number is 65002, and R3 S number 65003. Okay, so next is I will test the connectivity. Alright, so you have to understand that for both R1 and R3, the crypto map is on. Let me check first. So you just need to make sure that the IPsec VPN works. Okay, so the crypto map is on. Right? So let me ping This one is PC2. So PC2 ping PC1, ping 192.168.1.126. So because the VPN is working, so basically the ping from the PC2 to PC1 should work as well. And in this case, if I issue the command show crypto IPsec SA, so basically there is an encryption of the IPsec packet. So meaning now the tunnel is working. So what we want to prepare is we will remove all of the IP route, meaning the static route and default route for all of the routers, because we do not want the connectivity, end-to-end connectivity between the routers use the default and static route. What we want is we will remove all of the default and static route and replace it with the BGP routing, because static of course it's working, but for the purpose of verifying connectivity using BGP, so we need to remove the default and static route first. Otherwise we won't know that the BGP works. Alright, because we have two mechanism of routing from end-to-end for end-to-end connectivity. So first I will remove the default route on R1 and R3. So no IP route 0.0.0.0, 0.0.0.0, and S0/0/0. Okay, I guess if I show run, I'm using NetHop, I guess. Yes, I'm using NetHop. So what we have to do, you can always just copy and then remove it. Alright, so please remove the default route for R3 as well, because we do not want the connectivity is done using the static route, okay, because we are going to configure the BGP dynamic routing afterwards. So I remove the default route on R3. Okay, so missing IP route command. Okay, so now the default route has been removed from R1 and R3. So if you are using the NetHop, so you just replace the SE interface with NetHop address. Now on the ISP, because it's too long, so I already paste the configuration, but I put no. So what you have to do is just go to show run and paste the configuration on Notepad and add no command in each of the lines. Okay, so we are done with removing the IP route. Now another modification that you have to make is prior to the BGP. So I have already we have already configured the ACL, right? So if you look into the ACL here, so this is the ACL that we have. Okay, so similar to the IPsec VPN, if you apply the ACL on R1, so basically we need to allow and permit the VPN traffic by specifying the ISMP and also the ESP header. Okay, so now given the situation where we want to configure BGP, we also need to allow the BGP traffic. So basically what you have to do is you need to remove the current VPN SEL, and you need to add these two lines, the one in the yellow highlight, to allow and permit the BGP traffic that matches both outbound initiation and inbound return traffic. So it needs to be both. Alright, so basically here you can see that we need to permit TCP any EQ179 and permit TCP any EQ179 any. So for the first line, it is to permit the outbound TCP, which allows a BGP session initiation where the destination port is 179, meaning, for example, the connectivity between R1 to ISP. But for the connectivity between ISP to R1, you need to make another permission to allow the return traffic where the source port is 179, which is the 179 is the BGP protocol. So what we have to do is on R1, so I have prepared it here. So first I will need to remove it, remove the VPN SEL. So I'll just paste it, and then I add two lines to allow and to permit the BGP traffic. So all of this, just copy it and paste it. Okay, so now we have give permission for the VPN traffic and also for the BGP traffic. So fast forward and let us test again. So here we need to ping from PC1 to PC2 or PC2 to PC1 vice versa. So I just ping from PC2 to PC1. So you can see that the destination host is unreachable. So why is it unreachable? It's because now on the public internet, on this part, there is no mechanism for routing for the public internet, because you have removed all of the static and default route for R1 and R3 and also ISP. You remove everything. So basically there's no routing on the public internet. So for part 2, you will learn about the BGP routing.